Hello, good morning everyone. Thank you Cedric for the introduction. It was well given and I hope everybody is ready to start listening to the presentations, and as said, if there is any questions, add them to the chat and our colleagues can then look into them more in detail. My presentation today is related to construction market drivers, and the agenda for the presentation is as follows. So first of all, we look at a bit on the changes that are expected to come on the business environment. And then we look at the construction market overview, of course looking how is the expected future also within a couple of years where we can find data. And additionally, I have information about wood construction shares in flats in different European countries, which I hope you find also extremely interesting. So I will start with the business environment part. So first of all, this is of course something to follow up, see how does the market changes, how do you feel, how does that link to your business, but at least to give an idea what to follow up. So first of all, looking at this from a construction product distribution point of view, so the expected future looks like such that there will be large hubs that are serving these products to the customers that are needing them. We see this kind of events or influence already happening in European market, and especially these hubs are then able to add value for their customers, and these added values could be such as custom packaging, they could be cut-to-size services, or they could be very fast delivery due to the extremely closeness of the customers. On the other hand, when we look at the construction industry, we see that there are large prefabrication companies arriving. They build products utilizing wood, steel, lightweight products that are easily shipped to construction sites. The main thing that we notice in relation to these companies is that they tend to go upstream in the procurement. So they more and more buy products directly from manufacturers, whether it's a wood product or a fastener or insulation or something like that. And the final, I would say, big note on this topic is related to the on-site traditional construction work. So current estimation is that 80% of that work can be transferred to be done in factories, in element production sites and mills, meaning that there is definitely improvements possible to gain with efficiency, with safety, and so on. Next one, I concentrate a bit on the changes, especially on sustainability related topics. So first of all, the information demand on sustainability is increasing, I would say, almost every day, and more demand are coming on this topic. So as an example, more information about the actual supply chain are needed, and that's also linked to the origin of raw materials, for example, wood products. And that kind of requests are coming from the market. I'm sure you have also recognized the demand on that. Next or second bigger thing is related to ESG reporting, or environmental, social and governance. And that's actually something that is becoming mandatory for all companies in Europe, and they actually starting up so that the large companies actually must already start the reporting on next year's numbers. So full year 24 is the first year they have to report. Then gradually moving into smaller companies, so that the latest one is that all the companies in Europe must give also this information out from year 28 onwards. And then the final topic which is also visible on the market, is related to countries, municipalities, companies setting emission targets. And they are also seeking on reducing their emissions. And for example, I was in event in Sweden where we discussed this topic, and the presenter said that depending on which year you start the production, the limit of the emissions per square meter is also decreasing or declining per year. So it is definitely something to keep a close eye on the business front. Then looking a bit the construction market as a kind of big overview. So first of all, the global, and I'm now talking about the whole planet here, the market size is 13,000 billion euros. So it's a big pile of euros. If you compare that to gross domestic product, it represents roughly 12%. And in Europe, the same figures are in level of 2,600 billion and representing 16% of the European gross domestic product. So in Europe, it's a bit bigger market than for example, globally. Then if we look at the construction material usage of raw materials, so about half, so every second kilogram of stuff that we use in this planet goes to some form of construction. That's a big amount of materials used everywhere, all day. So definitely something to keep an eye. And I also know that my colleagues are presenting topics that help you to look into this topic in more in detail in today's event. And the final one here, which I want to take as a global comment, is related to greenhouse gas emissions. So construction industry contributes about 1/3 of the global emissions. And again, they are a big amount of that. And of course, there are plans and targets to reduce this one. If putting that in numbers, so roughly 2/3 of the emission are related to heating, cooling and such energy usage, and 1/3 is related to construction materials.
Thank you, Jussi, for this excellent presentation and the great overview you gave us. We haven't received questions from the chat so far, so do not hesitate to ask again. Don't hesitate to post your questions. I have one. I remember when preparing these webinar, we have talked about the changes in the design environment for perhaps especially for engineers. Could you tell us and give us a word about this, please?
Yes, definitely. So in engineering side, so design side, the main like closer term change what is expected is related to Eurocode updates. So within, let's say 26, 27, we are expected to have the new Eurocode available, and that will have an effect on the structural design side. The other one we are looking to be even a longer term is related to construction product regulation, which is the background data that gives, for example, the CE marking for the products and so on. But that's related all the construction products, all the CE marked that you are expected to see as of today.
Yeah. And since we have a bit of time, perhaps in particular for LVL, what is expected to change or to be improved in these new regulation? Is there any change to that we could anticipate?
What you can expect is that LVL is more included in the Eurocode as well. So it means that more of the data that you would need on your daily design is already available in the material that is upcoming. So that should help everybody to do the design and at least to see that would it fit to the project they are designing better than some other products, and would that perform in a way that is needed.
So it's time now to welcome our next speaker, who is Niels Draxler. So Niels will be presenting remotely. So Niels, are you connecting and hearing as well?
Yeah. Hi.
Great. Guten Morgen, Niels, and welcome.
Good
Niels will
morning,
be,
everybody.
I hope everybody can hear Niels correctly in the audience. It seems to be the case. So Niels will be speaking about the material efficiency of Kerto LVL. So Niels, please, the stage is yours.
Thank you, Cedric. Yeah, good morning, everybody. So my name is Niels Draxel. I'm a timber engineer and working now for Metsä for 1.5 years. So my part will be talking about the material efficient use of Kerto LVL. I assume you see that poll now, so please fill in that one during my presentation. So I want to start with that beautiful swimming hall in Luxembourg, built by Holzbau Ammann as a first inspiration for you. So instead of using massive, for example, glulam beams in combination with a CLT, they used a kind of a rib Kerto floor roof. So just using elements by 23 meters by 1.80 meters, and placing them on top of that roof so that the roof was closed pretty fast without using too much material on site. Yeah, so starting now with a short overview of the content. So I'd like to show you the use of Kerto in big size panels and elements, so roof and wall elements, some examples, then how to use it in modules, short comparison of 2 different floor systems, the application as a lintel, which probably is known by you, and the cut to length service that we offer. So, whoops, that was a bit too fast, but anyway. So, yeah, no, everything's good. Okay, so starting with roof panels. We think the use of Kerto panels as a roof panel might make sense in different applications or different situations. So using, for example, a bigger panel size 2.50 meters by 8.60 meters, for example, cut to size. So it comes to the construction site and you just take the panel, put it on top, and it's done. So no cutting on site, no nothing. And then saving some material and time in different perspectives. So on the one hand, saving, for example, as a wind bracing or stabilizers that you normally need, no matter if it is steel or glulam. Then, as I said already, you have less cutting waste due to the customized panel sizes. And thinking about using a Kerto Q panel or L panel instead of a thicker CLT, you might end up in this example with 39 millimeters compared to 60 millimeters CLT, with a material saving of 35%. So now coming to the next example. This is this wall panel application. So using a big sized panel instead of a couple of smaller ones. So one element is equal 1 panel. So in this example, it was a concrete prefab concrete hall in the Münster, next to Münster, so in Germany, made by Brünninghoff, that they used element size of 2.50 meters by 13 meters. So the element was that size and the Kerto panel was the same size. So we have less work in the factory. You have no cutting waste in the factory. And of course you need less connectors because you have less joints of the panels. And big advantage on site as well. You just close roughly 30 square meter facade in one step. So you win speed and safety on site. So talking about now about the modules. So you can think about different uses of Certo in modules. You can think about whole Certo boxes. So like a shoebox, for example, just everything made of Certo, floor, ceiling, walls, or as part of a timber frame construction. You can think about it in steel or concrete frame modules, just as a filling between that frame. Or like we used it, for example, in a school in Berlin, just having a high performance beam of re-glued Certo. And so now going a bit more in detail with one example. So thinking about a Certo module made of 57mm Certo Q instead of an 80mm CLT, you going to save 23mm on each side. So you do not only save material, but the investor will also win some floor space, only 23mm per panel, but this could end in a significant amount. So on the one hand, you have the material saving of 29%, and on the other hand, assuming a module, for example, 3 by 8 meters, you will end up with roughly 1,500 euro added value per module. So which might be a significant added value for the investor, of course, depending on the sellable price and so on. So what about floors? Sorry. Certo can be used in floors in different ways. It can be used as a rebar element, no matter if it is an open box element, a box element, or a rib element, the normal way and upside down. Or you can use it in combination with other materials like a glulam beam or something else. Yes. So what we were asked a lot and where we thought a lot about was what about the comparison with, for example, CLT floor? So do we need very high elements, or can we have, can we come to the same height, so the same mechanical properties by using a box element? And we ended up with the build-up you see right here. So we have the Certo S-beams, 45mm wide, and Certo Q panel on top and on bottom, everything glued together, and Certo Q panels of 45mm as well. So we ended up with 240mm in total as well. So same height, same mechanical properties, and one big advantage regarding the sound protection. So we can put in the heavy stuff, so the gravel or concrete blocks or whatever you use, putting it into the box, and so saving a total floor height without losing in sound protection or any other things. So in this example, we ended up with 50mm less floor height, which we can use either for more room height or less building volume, or we can optimize the rebar element even more by increasing the height, and so making the panels and everything a bit more slender. Yes, so in this comparison, like it is here with 45mm Q panels and S-beams, this results in material saving of 55%. So it could be even more if we optimize the box element a bit more. So related to the floor, so the connection to the wall is that lintel. So I have a few examples here. So, but first starting with that, I would say solution, most common solution, that massive one. So we have a timber frame wall, we have a glulam beam on top as part or as a bottom chord. Upper chord, sorry, and then we put the timber floor on top of that timber frame wall, and on top of the timber floor is the next timber frame wall again. So this works in some application, but often there are different questions. So regarding the building physics, like what about the dew point, what about vapor barriers, thermal bridges, what about room high windows, what about settling, especially on higher buildings, or if you have a plastered outer wall. How is the load transfer going on? What about roller shutter boxes? And finally, what about resource efficiency? So the big question is, why not using a Care2 LVL beam, like that clever guy from VVR does? Could be, for example, in 39, 45, 51mm, depending on the geometry of the wall and of the structural requirements. So here I will show you a couple of examples just to give you some inspiration how to use the Care2 beam without thinking too much about building physics, space in the wall for insulation, roller shutter box, and stuff like that. So first one is a simple beam, like you have it on the picture, and you can connect the beam shoe there, place your beams in the beam shoes, and it's done. So pretty simple. Next one is a bit different. So idea here was to avoid cutting the studs. So we placed the beam, the Care2 beam, in the installation layer, and yeah, so we avoided the cutting. And in this example, we used a metallic dovetail, so a Sherpa or HVP, you name it. This is an inspiration for this one. Then next one is that L detail, which maybe is known by you as well. So pretty simple to place the floor, and that's everything I want to say here. Sebastian will talk about that detail, about that detail more detailed in the next presentation. So pretty exciting what he's going to present. Then last but not least, we have the normal dovetail connection. In this example, we thought about an element made of beams with one end beam, and the connection between the main beam and the end beam is with a dovetail. And then you screw that element to the beam that is implemented in the wall, so the lintel there. And how I find quite impressive side note there is that comparing the capacity of C24 with Certo LVL, you can double the capacity of the Dovetail, just by using Certo. And comparing those now with the glulam beam I just shown before, so same mechanical properties again, just a bit thinner, you can end up with material savings of up to 65%, so 2/3 of the material just saved by this one, with a lot of advantages. So what about cut to length? So that's one service we offer, and this is, so cut to length means, so we deliver the length you want to have. So if you want to have 3.58 meters or 8.20 meters or 11.12 meters, we will deliver this to you. So you don't need to cut it in your production facility. So you can send it directly to the construction site, for example, or just use it in your prefabrication process. And so we save material on two sides. So on one side we save material in our production, because we have an endless production and we have almost no cutting waste in the production itself. And due to that cut to length delivery to your site, you will end up with no or very little cutting waste in the carpentry as well. So coming now to a quick summary of what I just showed you. So on the one hand, you can save timber, like I've shown in some examples now, just by using thinner material, or just using the material in a bit of smarter, more efficient way. You can save supporting structure, like in that roof example. You can save connectors by using big size panels, so not tons of joints between the elements or between the panels, the cladding. You save cutting waste, which might be depending on the product, or if it's glulam or CLT or whatever, it can be quickly 5, 10 or even more %. And you avoid headaches about building physics. And finally, using big-sized panels in element production, you save a lot of work, of course, as well. And on the other hand, you will win space in the elements for insulation, roller shutter boxes, any other blind systems. You can win floor space, thinking about thinner walls, and with the size of the elements, you can win safety and speed on site and off site. So on site, especially thinking about closing the roof very quickly by using bigger elements, so less issues with rain or something like that. Yeah, that's it from my side. So I say thank you very much. A final word I want to say is, so we're having a very, very precious material called wood, and I think it's very, very important for all of us that we don't waste it just carelessly by using massive wood members just because it might be a bit easier in the beginning. So let's build more with less. Thank you.
Thank you, Niels, for especially for these last clever and inspiring words. I've been amazed by your presentation, especially the exceptional material saving in line with your last words. So, up to 30, 50%, 65% in some cases. So thank you for having very well spotted these material saving gains and benefits. We had a question in the chat about the standard dimensions. So for these lintels, are there any standard depth or height for these beam? The thickness you have told about 45, 51, 57, but what about the height of the beam?
We have standard dimensions, not for the lintel itself. So we have some standard dimensions that we offer on the stock or from stock, and we have pre-dimensioning tables for the lintel. So both we can offer to send them to you, whoever made that question or whoever asked. So just let us know and we will send you the information you need.
Okay, so thank you. Probably I guess that this information is available on the website, so it would be great if this link could be added to your presentation for the material. You're probably seeing the results from the poll about the material. So it appears clearly that Curto LVL S-beam and LVL Q panel are well known from you, but it seems that Curto T and L are less known. So could you please give us a word about the differences between S and T and Q and L?
All right. So different between Q and L is what is, so Q and T, these are the strong materials. So there we use the heavy veneers. So these are a bit heavier. So raw density is 480 kilogram, and of the others is 410. So it's a bit heavier and better performant. And yeah, so Q and L belong together because it's both cross-bonded, and the S and T belongs together because they are both parallel bonded. Yeah.
Okay, so thank you. I hope it's now clearer for everyone. I guess this information is also available on our website. So in case you'd be interesting to be on these mechanical properties, you can go to our website and find the relevant material. Another question is about how are connectors calculated for use in LVL according to current and future Eurocode compared with SolidWood?
Not sure whether I understand that right. We said comparison of SolidWood. So in general, the calculation of LVL is regulated in the Eurocode. Maybe Cedric, you can say something about the future Eurocode because you're there deeper in the detail. And there are some, let's say, additional information in the LVL handbook, for example, that you will find on the homepage as well.
Yeah, about the comparison with SolidWood, what I can say is that some connector manufacturers usually provide values for different supports. So some of them provide values for connectors installed in timber, installed in glulam, installed in LVL, mainly depending on the density. So, but it's correct, Niels, to spot here the LVL handbook where you may find material for the calculation and the design of the connectors. Perhaps not the hanger itself, but the fastener actually. So Niels, thanks again for your great presentation. We will now jump to the next one, and I am pleased to welcome Sebastian Lib from the company Pierre-Ming Young. Sebastian will be presenting himself in a few words, and he will speak about the business value with using LVL L-beam. So, Sebastian, the stage is yours now.
Is everyone hearing me?
Yeah, yes, I think so. Yeah,
Oh,
please.
perfect. Hello everyone from Switzerland. I'm presenting you some informations about the L-beam. And my question is, who has not trouble yet solving the connection between the ceiling and the outer wall with all its requirements? So today I show you a solution with the L-beam, which we usually use as a standard in many projects today. So my name is Sebastian Lieb. I'm a skilled cabinet maker and timber engineer, and now I'm working as a timber construction engineer at Pierre-Ming Young in Switzerland. And as a project manager for structural design, I have already planned a wide range of buildings, from multi-story residential buildings to big structural halls. Pierre-Ming Young itself is a planning office with several locations in Switzerland and Germany, and we plan and accompany timber buildings in the areas of structural design, building physics, fire protection, sustainability, and reuse. First, I would like to show you some advantage of the L-beam detail. Here you can see how two L-beams are installed in a reference object between the ceiling and the wall. On the left, you can see the cut in the area of the wall, and on the right side, you see the same wall is cut in the area of the window. Using this example, I will try to show you the advantage of the L-beam. In this example, a wood concrete composite ceiling is used, but the L-beam also works with other ceiling systems, such as Niels showed you in the presentation before. In the detail above, the red line presents the airtight layer. The airtightness layer can be created easily in this detail. It is also relatively far inside the construction, and this reduces the risk of conditions inside the construction. The yellow line represents the insulation level. Since the L-beam takes up little space in the wall, it can be easily insulated. This reduces thermal breaches and makes high energy buildings easily to implement. The blue line on the outside is the wind density level. This can be guided sufficiently outside the insulation level. The L-beam helps us to implement today's building physics requirements. Depending on the wall thickness, the roller shutter box can be integrated relatively easy in the wall. Depending on the window position and the architectural wishes, the position in the wall can shift, as you see in these two examples above. The lentil height above the window can also be significantly reduced compared to a conventional beam. Of course, the beam height depends on the span and the load from the ceiling. The size of the L-beam therefore varies depending on the project. With these measures, the architectural wishes can usually be taken into account. When an L-beam is installed, the column only needs to be notched locally. This helps the column to be placed on top of each other with a pin. The columns stand directly on top of each other, and crosswood can be reduced with this system. To reduce crosswood is particularly important for tall buildings in order to reduce settlements. The load from the L-beam can be transferred into the column via contact. The high strength of Certo helps to reduce the width of the supports. Since Certo also contains transfer layers, it is the optimal material to withstand the transverse pull in the web and the L-beam. The connection of the support bar and the web is crucial for the L-beam. In the past, we tested various L-beams to optimize them and to verify our design approaches. In the picture above, you can see the test setup, what we tested in the past. Part of this test was to check various connections between the support bar and the web. Here you can see the 4 different test setups. In the first series of tests, we connected the support bar and the web using screw press bonding and a transfer tension screw connection in the upper area of the L-beam. In the second series of tests, we omitted the cross tension screws and only connected with screw press adhesive. In the last 2 series, on the right side, we connected the web and the bar with a different number of screws without any glue. The test specimens were driven until they broke. You can see the results in the 4 pictures. The beam with screw press bonding and transfer tension screws delivered very high strength values and failed in the wood cross sections. The second beam with screw press bonding and without transfer tension screw failed in the join due to transfer tension and achieved significantly lower strength values. The screwed L-beams on the right hand also takes a significantly lower load, and this results in a large deformation between the web and the bar. On this diagram, you see the same 4 tested beams. In the x-axis, you see the deformation, and the force in the epsilon axis. The 2 screw press bonded beams are shown with the orange and the blue line. The big difference in the load-bearing behavior of the two beams is thanks to the transfer tension screw connection. The screwed cross sections are much less rigid. You can see this in the brown and purple curves, which get much greater deformation as the other two tests. I can explain to you why the transfer tension reinforcement has such a big influence with the following pictures. With our L-beam, the support force acts as eccentrically on the beam. So this eccentrically results in an offset moment on the beam. The displacement moment can be divided into tensile and compressive forces. Since wood cannot absorb large transfer forces, the tensile force must be reinforced in the cross section with fully threaded screws and in the upper part of the support bar. In Switzerland, we usually use press bonding with fully threaded screws in our L-beams to achieve the maximum strength. In Germany, not every woodworker can carry out screw press bonding, so sometimes only screws are used in this L detail. But then the additional deformation must be taken into account to the structural concept. Test results before showed that an L-beam without transfer tension reinforcement is not recommended from our side. In summary, the L-beam helps us to create a slim and efficient load-bearing structure and to meet the high requirements in modern buildings. With Kerta-Q, we have the optimal material to create these L-beams. I hope you were able to take some new aspects away from this presentation, and thank you for your attention.
Thank you, Sebastian. Thank you very much for this in-depth, very technical presentation. Before we go to the question, we would like to ask you now your active participation into a poll that is launched now. And the question is, how do you, what would be your keywords to describe the value of this L-beam? So the value of using this L-beam. So take a few seconds to think about this and how you could perhaps do the same or do it differently. But yeah, so please take a few seconds to reply this poll. Okay, so thank you for answering. We have a few questions. First one, what about the diagonal screwing in the L-beam? So I guess the question is about these screws you have inserted. They are horizontal, so perpendicular to the veneers. What about having them inclined? It's presumably more resistant, so have you considered this option?
No, we haven't tried that since yet. I think it's a little bit, it's not that easy to screw the screws in like this for the woodworker. So maybe that's the reason why we didn't tested it since yet.
Okay, thank you.
Normally the horizontal screws are enough for the L-beams.
And I would have a question on these tests you've made. It's very in-depth engineering and design. Were the tests at some point surprising, or the test results surprising for you? So could you sort of in advance anticipate which type of connection would be the more resistant or the more ductile or whatever property? So were the tests surprising for you?
No, I think the tests didn't surprise us. We tested it in the past because we want to know how much this screw in the upper part help us to get some more load on the L-beam, and especially we want to know are our design approaches correct, or can we optimize them, or do we have to change them in any way?
And last one, you gave very quickly a word about this, but about this certification, you told that in Switzerland you were sort of allowed to use the combination of structural gluing and screws, while in Germany, for example, only screws are allowed. In terms, I think, to the control or checking engineers, what have you used to justify this connection? Have you used the test results or the design that you had made beforehand?
Yes, in Switzerland we only need this test results to use this L-beam. We only have to be sure that it is working, and in Germany it's a little bit different. They need for nearly everything like a certification, and not every woodworker can glue two parts together for static elements. Yeah, that's the difference. But I don't know exactly what you need in Germany to do it. Yeah.
Thank you, Sebastian, for these clarification. You should be seeing the results of the poll, so not too many answers if I see, as far as I can see. Two things that are spotted is the space that is left in the wall, I guess, for the roller shutter, and clear building physics, perhaps the building statics that you have shown, Sebastian. That was very clear and very, very important for engineers that are attending the webinar. So thank you for your presentation again, Sebastian. Now it's time to move on. We are, despite the technical problem, not on late, but it's time to move on. So we've gone through the benefits from the very large picture with UC, with very detailed and concrete applications with Niels and Sebastian. And now we will approach the topic by the sustainability side. And so I'm pleased to welcome Rosa, who's our sustainability manager at Metsä Wood. So Rosa, the stage is yours, and welcome.
Thank you, Cedric, and good day, everybody. Today I will talk about the sustainable practices and how they help to build a thriving business. The focus will be on biodiversity and then the sustainability service offering of Metsä Wood. But first, I think there should be a word cloud next to the chat. So there's a question, so please go on and fill that. But first we will start with the presentation, and let's start with the biodiversity. So in short, what does the biodiversity mean? It's a variety of life on Earth, and this includes different species such as animals, fungi, also the genetical diversity within these species. And the biodiversity is critical and essential for the ecosystem's functioning, its stability, resilience, and also providing the ecosystem services. couple example of the ecosystem services provided by the northern forests could be, for instance, water purification, nutrient cycling, pollination, and food and oxygen production. So quite important services for the human well-being and then also for the overall health of the planet. Diverse ecosystems are more resilient to environment changes, which then helps us to mitigate the risk caused by, for instance, climate change. And this improves then also the supply chain resilience and helps us then to ensure that the raw material availability is secured also for a long term. Then why does especially the forest biodiversity matters? Majority of the terrestrial biodiversity is located actually in the forest. And if we look at the map here, especially the green and blue parts of the map, these describe the global biodiversity hotspots. And if you notice, they are mainly located in the tropical areas, thus it's essential to pay special attention when sourcing raw materials from these areas. But as we know, the tropical forests are very different from the Nordic forest, and the species between these forest types are differing a lot. So taking care of the biodiversity isn't something that we can outsource, but we must take care of it also on local level. And coming to local level, and what does it then mean from our northern forest? Here also in the Nordics, the warming climate is affecting then the increasing risk coming to forest damages, such as forest fires and windstorms. So this is already creating a risk to the raw material availability. But the warming climate can also be sort of a benefit for the northern forest, as we get in the Nordics a longer growing time for the trees within a year. So when we are taking care that the forests stay diverse, they also stay more resilient and adaptable to the climate warming, and it even gives us a chance to take advantage of this warming. Then if we are looking a bit about the legislative perspective and what Metsä Group is doing. So in Europe, climate and biodiversity are taken into account already on both EU and national level. And for instance, in the Nordic countries, a law already requires set this minimum requirement where you have to plant new trees in the forest when the trees are cut. And then on top of these, for instance, in Finland, we have these best practices for sustainable forest management, which are based on the most recent scientific knowledge and social values. On top of these national level requirements, we have then these global voluntary forest certification schemes such as BFC and FSC, and these set then the requirement for sustainable and responsible forest management that meets also then the international requirements. But we can do actions that are in addition also to the forest certification schemes. So for instance, in Metsä Groups, we have our ecological sustainability program, which is basically a program to put into practice our goal of regenerative forestry. And regenerative forestry, we mean that we leave the forests that are in commercial use in better condition for the next generation compared than what they were before. And on top of this ecological sustainability program, we have nature management program, which is then focused on financing development projects that are outside of the commercial forests. So for instance, financing restoration projects or getting rid of invasive species. And on top of these programs, then we have our Metsä Plus model, which is then designed as a compensation model for our owner members. So we are owned by Finnish forest owners, and for them we purchase our wood. So when the forest owner is deciding to make additional biodiversity actions that come on top of the certification, then we give extra compensation for them for those actions. Then how does the everyday forestry in Metsä Group, when putting into practice this ecological sustainability program, actually looks like? So we leave, for instance, standing and fallen dead wood in the forest that provide living places then for the species that are dependent on the dead wood. We also leave groups of retention trees to form more decaying wood with time. And there we are, as the retention tree group is left untouched, it serves also as a sheltering ticket for the animals. And at the very behind of the peak, you can see a group of aspens, which is known to be important for many species. So those are also left untouched. And when replanting the trees, we are only using first of all native species, and there again here creating the diversity within the forest. So not planting just one tree species, but 2 or 3. Then at Metsä Group, when we are sourcing our wood, we always make sure that no matter whether the wood is coming from certified or non-certified source, we always make sure that it's coming from that first of all it's traceable and that it's coming from legal and responsible sources. All our mills are chain of custody certified, which enables us then to trace the wood supply chain. And these procurement principles are same in all our wood sourcing areas. Then a bit about the forest certification. So forest certification guarantees that the forest has been used legally and managed sustainably and responsibly. On a global perspective, around 10% of the forests are certified. And when in comparison, then around 90% of the wood that Metsä Group uses is certified. And we can see one of the reasons, of course, we are preferring the certified wood. But if we are looking at the wood procurement area of Metsä Group, we see that also the availability of certified wood is very good for us. And here from the map, emphasizing also that the availability of certified wood isn't as good in every country. So here again, paying attention to the origin of the raw material and making sure if procuring wood from the countries where the availability is quite low, to pay extra attention and asking the supplier to provide how do they make sure that the wood is actually traceable to sustainable sources. And if also to mention that if you remember the global biodiversity hotspot map couple slides before, you can see that quite many of those hotspot areas are also located in these areas where the certification level is quite low. So again here, paying special attention. Then what does the forest certification and chain of custody certification means? So first of all, we have a forest owner who decides whether they want to certify their forest or not. And then, so that's the certified forest there. Then, for instance, our sister company, Metsä Forest, supplies the wood for the forest owner, and then the wood comes to, for instance, the Metsä Woods Punkaharju mill, which has then the chain of custody certificate. And this means that we can track the origin and are able to sell certified products then forward to our customers. So summarizing a bit, it is important that the forests remain forest and are in good condition due to climate change and biodiversity. When purchasing wood material and when making it responsibly, here are just a couple things to focus on. So first of all, prefer the forest certification and chain of custody certificate, and there remember to check the supplier certificate that it's first of all it's valid, and also the scope of the certificate, so that the product and mill you are procuring from is included in that certificate. Then also paying extra attention to the country of origin, and you can always ask from the supplier any additional actions besides the certificates. Then moving on to our sustainability service. So first of all, if there's any need for sustainability support, or you just want to have a general discussion about sustainability topics, please contact your Metsä Wood sales contact person and ask them to arrange a meeting. So our offering includes, for instance, certificates and comprehensive documentation of both products, mills, raw materials we are using. We can give support in different environmental impact calculations, such as carbon footprints or carbon storage calculations. We can also offer customized trainings based on your needs regarding different sustainability topics. And now looking what we have offer as an we have quite a lot of services offered publicly for all in our web pages. So here going through some of them, first being the carbon storage, where you can evaluate your purchase carbon storage. Then we have just published our Metsä Wood fact sheets that are about the forest certification, Nordic forests, and also carbon calculations. So these fact sheets are made to support you on daily basis, giving information whether you use it internally or with your customers. So we have made this very neutral, and these fact sheets, for instance, don't include our product's name. Then also publicly available for all, we have all our mills management system certificates, and then also our chain of custody certificates available. So when I mentioned that you should check the validity and scope of the chain of custody certificate, so here is where so from our website you can go and check our. Then we have also product-related environmental impacts calculated and available for all. We have made these environmental product declarations of our products, which are third-party verified environmental impact calculations. And here again, if you need any support, for instance, on how to utilize these EPDs, please contact your Metsä Wood sales contacts. Thank you for your time.
Thank you, Rosa, for your excellent presentation. Again, another. Yes, we have to stick in the camera field too. Yes, for this approach via the benefits from the sustainability point of view. There's been a question on the chat about the share of certified wood, but I think you have answered this. And
yes, around 90%.
Around 90%,
yeah.
Okay. I think these fact sheets, where is it possible to get them, the fact sheets?
So the fact sheets are available on our web pages.
Okay.
So if you go to our sustainability web pages, there are guidance on how to find them.
Okay, thank you. They had also a question about more for Jussi about how the CO2 discussion will be affecting the construction sector and segment in the coming years.
Yeah, so there is some regulation coming related to taxonomy and that will require to take into account several parts of the emissions, of course, like we discussed on my presentation already earlier, but also taking into account the usage of raw materials. Are they recycled or are they from primary sources, and so on. So definitely something to keep in mind, follow up closely, as that will influence the business environment in the coming years. Good question.
Okay, thank you. And I would like, yes, to have a look at the results of the poll about sustainability. So perhaps, Rosa, will you have a reaction seeing these few words? Are these questions that you are familiar with, that you may answer?
Yeah, I see that there are especially reduction of materials, then recycling, and for instance EPDs. So here the first two, of course, focusing on the raw material efficiency, and I think this is critical. If we are, for instance, in the Jussi's presentation, we saw that the construction sector is using a lot. So I think this should be the main concern on how can we use actually less materials, and then the EPDs, of course, focusing then on that the reporting will increase, and the information flow and data points that we are asked, that will increase a lot.
Okay, yeah, thank you, Rosa. I think we don't have any more questions from the chat, so do not hesitate to use this chat to share your thoughts, your views, perhaps expectation for themes for next webinars. So it's something you can do. So please do. Now I would like to wrap up by saying that the recordings will be made available, also the presentations, and that you will be sent two things. First, a link to download all this material, and also a feedback form, so that we have your feedback. It is anonymous unless you want us to contact you. If so, you will leave your email address, but otherwise it's anonymous. And then thank you again to our 4 keynote speakers of today. Jussi, thank you. Rosa, thank you. Thank you, Niels and Sebastian, remotely, for your excellent presentation. And stay tuned, because you might be announced the next one, so we will keep you informed. So thank you very much for your attention, for your time this morning. It was a pleasure for me to host this webinar, and looking forward to seeing you soon. Thank you very much.